Section 5.1 is about midsegments. We've never talked about midsegments before, so let's first define it. A midsegment of a triangle is a segment that connects the midpoints of the two sides of the triangle. So, looking at the diagram, M is a midpoint of AB, P is a midpoint of BC, and N is a midpoint of AC. So therefore, the segments that connect the midpoints, MP, MN, and NP, are all midsegments. So the midsegments of ABC are MP, MN, and NP. And you can see that these are all midpoints because we have the tick marks indicating that they are halfway in between all of the segments of the sides of the triangle. With the definition of midsegments comes a theorem. This is called the midsegment theorem. It states the segment connecting the midpoints, otherwise known as the midsegment, of two sides of a triangle is parallel to the third side and is half as long as that side. So looking at the diagram, you can see that DE is a midsegment of this triangle since D is a midpoint of side AB and E is a midpoint of side BC. Once you identify the midsegment, you can assume that the midsegment is parallel to the side it is not touching, so DE is parallel to AC. And you can also assume that the length of DE is half of the length of AC. So if AC was 10, then DE would be 5. So again, the midsegment theorem tells us that the midsegment is parallel to the side that it is not touching, and it is also half the length of that side it is not touching. So let's look at some examples where the midsegment theorem is used. So in parts A and B, it states that segment MP is a midsegment of triangle LNO, and they want us to find the value of X. So again, we know that MP is a midsegment. According to the midsegment theorem, we know that the length of this midsegment is half the length of the side it is not touching. It is also parallel to that side, but in this case, we're only looking at the distance. So if NO is 16 units long, then MP is going to be half of that. So X is going to be equal to 8. In part B, MP is the midsegment, and in this case, when we're solving for X, it is actually over here. Since MP is a midsegment, I know that P is a midpoint of the segment LO. So again, if P is a midpoint, that cuts the segment into two congruent segments. So if it's 4 over here, it's going to be 4 over here. So X would equal 4. Here's another more in-depth look at the midsegment theorem. Example number 2. In triangle DEF, EJ, which is this segment right here, is congruent to JF, so I'm going to mark that. FK is congruent to KD, so FK congruent to KD. And DG is congruent to GE, so these two segments are congruent. That tells me that points G, J, and K are all midpoints of the triangle's sides. So therefore, GJ, GK, and JK would all be mid-segments of the triangle since they are segments that connect two midpoints inside of the triangle. So part A wants us to complete the statement. Segment GJ is parallel to blank. So GJ is a midsegment. From the midsegment theorem, we know that a midsegment is parallel to the side it is not touching. So therefore, GJ would be parallel to segment DF. Part B, segment EJ is congruent to blank and congruent to blank. So let's first identify where EJ is at. EJ is right here. We know that EJ is also congruent to JF. I would also know that this side is twice the length of the midsegment. So if the midsegment is half the length of this segment right here, and I know that this segment has been cut into two congruent segments, that means that each one of these segments would be congruent to the midsegment here, since together they are twice the length of the midsegment. So again, EJ would also be congruent to GK. Next we have segment DE is parallel to blank. So DE is right here. From the midsegment theorem, we know that it is parallel to the midsegment that it is not touching. So DE is parallel to JK. And then finally, part D, GJ is congruent to blank and blank. So GJ is right here. We know it is half the length of the side it is not touching, so therefore GJ would be congruent to DK and also KF. Example number 3, in triangle XYZ, points U, V, and W are midpoints of the sides. So before I do anything, I'm going to mark that U, V, and W are the midpoints of the sides by using tick marks. So if U is a midpoint, that would mean that UY is congruent to UX. If V is a midpoint, then YV is congruent to ZV. And if W is a midpoint, that means XW is congruent to ZW. Always mark your diagram with your given information. So first it states for part A, if UW is equal to 4x minus 1 and YZ is equal to 5x plus 4, what is the length of UW? So first off, UW is right here. That is a mid segment since it is connecting the midpoints. So UW is 4x minus 1. And YZ is equal to 5x plus 4. According to the mid-segment theorem, I know that the length of this mid-segment is half the length of this segment right here. So to set up this equation, because I'm going to have to solve for x to plug it back into the 4x minus 1 to find the length of UW, I'll set 4x minus 1 equal to half of the length of that other side, 5x plus 4. And then I'll solve for x. I don't really like the fact that I have this fraction right here, so what I'll do is multiply this side by 2 to get rid of that fraction. So doing so makes the problem so much easier to deal with. If both numbers inside of this parenthesis had been even, it would have been pretty easy to distribute the 1/2 and just divide both numbers by 2. But by the fact that this was a 5, it was just easier to double this side than to take half of this side. So the first thing I'm going to do is distribute. So I'd have 8x minus 2 equals 5x plus 4. Then I'm going to subtract the 5x from the right to the left, so I'd end up with 3x, and I'll add the 2 over, so I have 3x equals 6. Divide both sides by 3, and I'll get x equals 2. But remember, the problem didn't ask what x is equal to. It asked to find the length of UW. So now that I know x equals 2, I'm going to substitute 2 into the expression for UW, the 4x minus 1. So therefore, UW would be equal to 4 times 2 minus 1. 4 times 2 is 8, and 8 minus 1 is 7. So the length of UW is 7. Part B wants us to find the length of YV. YV is this length right here. If we know that the length of the mid-segment is 7, and I know that the total length over here is twice the length of the mid-segment, that means that half of it, YV, would also be 7. So again, YV would also be 7 units long. If it asked for the length of YZ, the big segment here, then I just would have doubled this answer and get 14. But since it's only asking for half of it, it's only 7, equivalent to the length of the mid-segment UW. Example number 4, part A. Find the coordinates of the endpoints of each mid-segment of triangle PQR. Now remember, the endpoints of a mid-segment would be midpoints of the triangle itself. So ST would be a mid-segment, SU would be a mid-segment, and UT would be a mid-segment. But S, U, and T would all be midpoints of the sides of the triangle. So when I'm finding the endpoints of each of the mid-segments, what I'm really doing is just finding the midpoints of each of the sides of the triangle. So S is a midpoint of segment PQ, and it would be over 3 and up 3. T is the midpoint of QR, and it was over 5 and up 1. And U would be the midpoint of PR, and it would be over 2 and it would stay there, so it'd be 2, 0. So this problem actually made it pretty easy because they asked us to find the coordinates of the endpoints of the mid-segments and they gave us a picture to work with. But let's say they didn't give you a picture and you would still have to find the endpoints of the mid-segments. Remember, finding the endpoints of the mid-segments is just like finding the midpoints of each of the sides of the triangles. So you're going to have to remember how to use the midpoint formula. So just for good measure, to write down one more time in your notes, I would write down the midpoint formula. Remember, you add the x's and divide by 2, and then add the y's and divide by 2. And again, I didn't end up having to use this formula because I was given the picture, but again, you may end up needing to use the midpoint formula if you were not given a picture to be able to identify all the endpoints of the midsegments. Part B says use the slope and the distance formula to verify the midsegment theorem is true for segment ST. Let's first draw in midsegment ST. So there's ST. The midsegment theorem states that the length of ST is half of the length of the side it's not touching, and it's also parallel to this side. So the first thing I'm going to do is verify that this segment really is parallel to this segment. I know that parallel lines have the same slope, so I'm going to find the slope of ST and find the slope of PR and verify that they are the same. Remember, slope is rise over run. So I'm just going to find the slope of ST by going down 1, 2, and over 2. So note how I wrote that. The slope, which we use m, of segment ST is -2 over +2, which in lowest terms is -1. Now, what I'm going to do is find the slope of PR and make sure it is also equal to -1. So I'll start here. I'm going down 1, 2, 3, 4, and over 1, 2, 3, 4. So again, pay attention to how I wrote this. The slope, m, of segment PR is -4 over 4, which is equal to -1. So far I have proven half of the midsegment theorem. Now I need to prove the other half using the distance formula to show that the length of ST is actually indeed half of the length of PR. So let's find the length of ST using the distance formula. Now remember, it's the one with the big square root. I first subtract the x's and square it, plus subtract the y's and square it. Remember, up here I identified what the coordinates of S and T are. So it's going to be really easy for me to subtract the x's, 3 minus 5, square it, plus subtract the y's, 3 minus 1, and square it. So I have 3 minus 5 is -2, -2 squared is 4, plus 3 minus 1 is 2, and 2 squared is 4. So I first have the square root of 8. Let's find a decimal approximation of that. The square root of 8 is about 2.8. Now let's find the length of PR using the distance formula. The coordinates of P and R are given to me on the diagram. So the first thing I'm going to do is subtract the x's. So 0 minus 4, and then square it, plus subtract the y's. So 2 minus -2, and then square it. 0 minus 4 squared would be 16, plus 2 minus -2 would be 2 plus +2, so that's 4, and 4 squared is 16. So 16 plus 16 is 32, and we'll get a decimal approximation of that. The square root of 32 is about 5.6, and 5.6 is indeed twice the length of 2.8. So therefore I have now proven both parts of the midsegment theorem, first showing that the midsegment is indeed parallel to the third side it isn't touching, and it's also half of the length of that third side that it isn't touching. Example number 5, a square has vertices of 0, 0, m0, and 0m. Find the fourth vertex. It is exponentially easier to do these problems if you draw a picture. So our first point is at 0, 0. So here's our first point, 0, 0. Next we have M0, so that means it's going out M units and it has a point. So right here on the x-axis I would have M0, and again I went out M units to get out that far. Next I have 0M, so that means I went up M units this time and have a point at 0M. So somewhere up here, M units out, I have 0M. So again, I went up M units to get up to that point. So if I'm trying to find that fourth point, which would be somewhere out here, I'd have to go M units this way and M units up that way. So therefore, the fourth coordinate would be M and then M, which would give me a nice square from here to here, just like that. So again, it asked me to find the fourth vertex. So the fourth vertex would be M, M. Notice I drew a picture to figure this part out. If you were to have any problems like this in your homework, I strongly suggest that you draw a picture just like I did. And finally, our last example, number 6. Place an isosceles right triangle in a coordinate plane. Then find the length of the hypotenuse and the coordinates of its midpoint. So let's first dissect what we're supposed to draw. An isosceles right triangle. So isosceles means I need to have at least 2 congruent segments, and I need a right angle in my triangle. To me, it makes sense to place it in the coordinate plane so that the right angle would be right here in the first quadrant. So the isosceles part would be that I have a congruent segment this way to a congruent segment this way, and then I'll connect the two for the hypotenuse. And since I'm placing it wherever I want, I can call the points anything that I want. So first off, again, I'm going to do the right angle right here, and then I'm going to go out, let's say, P units. So here would be P0. And then if I'm going to go up the same number of units this way for the isosceles triangle part, the next point would be 0p. So now I have 2 congruent sides right here and right here, and then I would have the hypotenuse connecting those 2 points. And I'm asked to find the length of the hypotenuse and the coordinates of its midpoint. So now I can just find the length of it using the distance formula, and then I will find the coordinates of the midpoint by using the midpoint formula. So first, the distance formula is the one with the big square root. So I would have the square root of, first I'm going to subtract the x's, so I would have 0 minus p squared plus, then I'm going to subtract the y's and then square it, so p minus 0 squared. 0 minus p is negative p, and negative p squared is p squared. And then p minus 0 is p, and p squared is p squared. So together I have 2p squared. I can actually break that down a little bit further. The square root of p squared is p, so I can actually put a p on the outside of here, and then the 2 would stay under the square root. So the length of that hypotenuse would be p times the square root of 2. Next, let's find the coordinates of its midpoint. So remember, for a midpoint, you add the x's and divide by 2, and then add the y's and divide by 2. So my x's are 0 plus p divided by 2, and then I would have p plus 0 and divide by 2. So 0 plus p is p divided by 2 is p over 2, or you could also just say 1/2 p. And then p plus 0 is p, and p divided by 2 is p over 2. And once again, you could also write that as 1/2 p. So those are my 2 answers, p times the square root of 2, and then the midpoint would be p over 2, comma, p over 2. That's it for this section, so make sure you jot down anything you don't understand. We will take this section pretty slowly, so make sure you're not stressing over too much of this, because we will go through it very slowly and figure it out as we go. And we'll see you then in class.